Okay, so in this video, we're going to be looking at quadratic number patterns. If you look closely, it says, given you're given 26, 45, and 70, and the third, fourth, and fifth terms of the quadratic number pattern. So let's write that down. So we're going to write down our terms that we have. This is the third term. That's 45. Second, that's the fourth term. And then we got 70. So basically this is Tn, and that is n. So we've got the third term, fourth term, and the fifth term. So we know that this is a quadratic number pattern, and in a quadratic number pattern, the second difference is constant. So therefore, our first difference is going to be a linear number pattern. So that's 45 minus 26. So let's find out that linear pattern. So we say 45 minus 26, that's equal to 19. And 70 minus 45, that's equal to 25. So our second difference is constant. So therefore, 25 minus 19 should give us 6. So if we look carefully now, we can work out what our second term and essentially what our first term is now going to equal to. So therefore, if we look at that, 45 minus 19 is 26. So if we have to work out our first difference here, 25 minus 19, and then 19 minus 6. So we can just work backwards. 19 minus 6 equals 2. So that's going to be 13. And then 13 minus 6, that's equal to 7. So we can say 26 minus 13, and we'll work out our second term. 26 minus 13. That's going to give us 13. And then 13 minus 7. That should give us our first term, which is 6. So we can conclude, therefore, T1, the first term, is equal to 6. Right, so it was a little bit complex there for 1 mark. So we got the first term there equals to 6. And we can work it out by setting out our sequence properly. Remember, n is the position of our term and Tn is our actual term. First difference. Also, please note that the first difference of a quadratic sequence is a linear sequence and the second difference is constant. So we are done with that. Determine the expression for the nth term of the pattern. So if we look at this now, our second difference is constant. So 13 minus 7. And then we got 19 minus 13 is going to be 6. So second difference is constant. 25 minus 19 is 6. So for 1.2, so what we're going to do is we're going to use our formula. Remember, 2a equals to the second difference. Now that's the formula that we use. So you don't have to write this down. You can just substitute 2a equals to 6. Therefore, a is going to equal to 3. And then the formula now to find the b value is 3a plus b equals to T2 minus T1. Or you can just say the first term of the first difference. So we're looking at these are the 3 values that we actually require. So T2 minus T1 is 7. Which is the first term of the first difference. So we're going to say 3a. So we're going to substitute a, 3 times 3 plus b equals to T2 minus T1 there. So that's 7. So 3 times 3 is 9 plus b equals to 7. And then we can say, therefore, b is going to equals to 7 minus 9 is minus 2. So we got negative 2. So b is equal to negative 2. And now we got c. So the formula to find c is a plus b plus c equals to t1, which is the first term. So now let's substitute. So we got 3 minus 2. So there's 3. We're just substituting minus 2 plus c equals to the first term. And the first term there is equal to 6. So 3 minus 2 is 1, and then if you take 1 over, you're going to get 6 minus 1 is 5. So C equals to 5. All right, so now you've got A, B, and C. So all that's left for us to do now is to substitute. Therefore, Tn equals to An squared plus Bn plus C. So that will leave us with Tn equals to, A is 3, so that's going to be 3n squared. And we've got B is negative 2, so let's write that down, minus 2n, and C is 5, so that's plus 5. Then it says, which two consecutive terms of the first difference will have a product of 7,735. So for 1.3, so in this particular question, it says, which two consecutive terms of the first differences? The first difference is sequence. Now we know that the first difference sequence is a linear pattern. So if we go back, then we can now see here what we have. We've got, as you can see, there's it. We've got 7, 13, 19. So we just need to write down those first three terms. So if you write down 7, 13, and you write down 19. So now what we can do is we can find the general term of this linear sequence. So we can now say that A is equal to 7, and then we can say that D is equal to 13 minus 7. So 13 minus 7 now is going to give us 6. We can say Tn equals to A plus n minus 1 times D equals 2. So we've got now A, which is there's the first term there, A, so n minus 1 times D. And our difference is 6 equals to 7 plus. So take 6 into the bracket, so that'll be 6n minus 6. It's going to leave us with 6n, and 7 minus 6 is 1. So that's going to be plus 1. So therefore, we got Tn. Now, what does the question say? It clearly says that two consecutive terms of the first differences of the sequence will have a product of 7,735. So therefore, now we just need Tn plus 1. So Tn plus 1, so two consecutive terms will be Tn and then Tn plus 1 equals to 6 into n plus 1 equals to 6n plus 6 plus 1 equals to 6n plus 7. So now we've got Tn plus 1 and we've got Tn. So this is what we require, Tn and Tn plus 1. So they're saying that the product of these two terms must equal to 7,735. So therefore, we now need to multiply these two terms. So therefore, we're going to end up now with 6n plus 1 times 6n plus 7 equals 2. And that's going to be 7,735. 7,735. So let's open out these brackets. 6n times 6n is going to be 36n squared. And then 6n times positive 7 is going to be positive 42n. Positive 1 times 6 there. So we're just using the FOIL method to open out these brackets. So that's going to be plus 6n. And then here we're going to get plus 7. Let's bring this term over to the left-hand side. So that's going to be minus 7,735 equals to 0. So now we got 36n squared. And then 42n plus 6n is plus 48n, and then 7 minus, so we're just going to say 7 minus 7,735, which is now going to equal to minus 7,728 equals to 0. Okay, so that's a standard form now. So now, right, because this is not your average quadratic trinomial or trinomial to factorize, so I'm going to use a formula. So A equals to 36, B equals to 48, C equals to minus 7,728. So now we're just going to substitute in the formula. Remember, n must be a natural number, right? So it can only be, natural numbers are counting numbers starting from 1. So that means we must take that into account. So x equals to minus b plus minus square root of b squared minus 4ac all over 2a. So let's substitute. Now we're going to say minus 48 plus minus square root of b squared, which is going to be 48 squared minus 4. A is 36, and then C is minus 7,728 all over 2a. So that's 2 times 36. So putting that in our calculator, we can say minus 48. Let's do plus first, so we say plus. So here we got the square root of 48 squared minus 4 times 36. And that's going to be minus 7,728 all over 2 times 36. 2 times 36 equals 2. So that's 14. So here we've got now n equals to 14. Okay. So here remember that we're solving for n. So let's just correct that. Okay. Let's get that. So that's our quadratic formula, or n equals 2. Let's see what our other value is. So now all we do is we just go here and we change that plus to minus. And you can see here we got minus 46 over 3. So you say not equal to minus 46 over 3. Because remember, n has to be a natural number. So if n equals to 14, so the two consecutive terms now will be, remember one, right? Consecutive means one after the other. So that means which two consecutive terms of the first differences sequence will have a product of 7,735. So it will be term 14 and term 15. So therefore now we can conclude that it will be T14 and T15. Right? Tn and Tn plus 1. Okay, and that should do it. So that was the first question that came out in our provincial paper in March 2026. Okay, all the best.